So we're going to be looking at linear and nonlinear functions, and we're going to say that an equation is linear if we can write it in slope-intercept form, which is y equals mx plus b. So graph-wise, we're just looking for one straight line. So if there's one straight line, then we're going to say it's linear. So for this first graph right here, this has two straight lines. It's actually an absolute value graph. So this is nonlinear. The next graph has one straight line. So we're going to say this is linear. And the third graph is also one straight line. So we're going to say that's linear as well. And the fourth graph looks like a capital U. That's not linear because it's not one straight line. Traditionally, for these tables, the input we're going to say is x and the output is y. So if it's linear, that means the slope is going to be the same. So let's just look at the pattern here and the points. So for the input to go from 2 to 4, we add 2. And to go from 4 to 6, we also add 2. And this trend appears to be continuing. And for the y values, the output to go from 36 to 44, we're going to add 8. Go from 44 to 52, we add 8. And that trend appears to be continuing. You can verify that. So that means we could write this table in slope-intercept form. So this is linear. For the other table, the input goes from 0 to 1. We're going to add 1. And to go from 1 to 2, we add 1. And this trend appears to be continuing as well. The output goes from 3 to 6, so we add 3. But though to go from 6 to 11, we add 5. So already at that point right there, we can say this is nonlinear. In another class, you'll be able to figure out what the actual equation is for this, to how to write this, but it's not going to be a linear function. And for the equations over here, we're going to circle it if it's a linear function. Essentially, you're looking at the exponents, and if the exponents are only 0 and 1, we'll be able to say that it's linear. So for this first one, y equals 1/3 x plus 8/5, that is linear. The exponent is 1 right there. That can be, it is in slope-intercept form. The next one is y equals 7x. That's also in slope-intercept form. The slope is 7. The y-intercept is 0. So we could rewrite this as y equals 7x plus 0 if we wanted to, without changing it. The next one, y equals 4. This is also linear because the slope is 0. It's a straight line going across. It would look something like, pretend that's a straight line right there. We would go through 4. There, I actually just put it out there. So this would be y equals 0x plus 4 as our equation. The next one, y equals 3x squared. That's not a straight line. That would look like a capital U, like the last graph did over here. It looks something like that. The next one, y equals 4 over x. The exponent is actually not 0 or 1. This is actually the same thing as writing y equals 4 times x to the negative 1 power. This actually is an inverse graph, and we'll look at that at another point. And the last one on here is y equals the square root of x. This is actually has an exponent of 1/2. And the graph would look something like this, like a half of a U, but off to the side turned. Note, if you were given something like y equals 7x squared plus 5x minus 7x squared, we need to simplify it first before you establish that it's linear or nonlinear. So the 7x squared minus 7x squared is 0, kind of goes away. So we're left with y equals 5x, and that would be linear. So if you have any questions, ask your math teacher.